Very good. We're going to have to multiply. Very good. Nice job, Bridget, Jaden, Lily. Jaden, very good. We're going to have to multiply because remember, fractions mean that we're doing division. So to undo division here, we multiply by 3 on each side. They cancel out on the left side. We're left with x is equal to how much? Let me think. 15 times 3 is...
Wouldn't that be 45?
Very good, Kaylee B. Yes, it would equal 45. Very good. Nice job, Jada Ramos, on that as well. Very good. Okay, I'm going to leave this up for a moment, and then we're going to move forward, but I'm going to leave it up so we can get this copy down first. Yes, here. Bridget.
Do you have to fill this out on the Google Slides too, or?
No, you're all set. And then Olivia. There's more people here, but I will take attendance in a moment. Oh, Faith was here too. Okay, so we have this guy here. Let's look at our learning target for today. Our learning target for today is going to be as follows. We're looking at this guy here, and we're throwing in a new idea. We can now determine whether an equation has no solution, one solution, or infinitely many solutions. We don't know what those mean yet. So let's take a look at some new vocabulary for ourselves. Okay? So if we slip and slide down to slide number 4, Kaylee, you can just watch on this one because it's not in your packet. Let's think about these two equations that we have right here. So this first one, we have 2t plus 5 is equal to 2t plus 5. First things first, I'm the realist. What do we notice about this equation here? Anything at all? Kaylee B.
Is there variable on each side?
So we have variable on each side, 2 t's, very good. What else do we notice?
There's a plus 5 on both sides.
There's a plus 5 on both sides. So what can we summation say about both of the sides of the equation? They are
The same.
they're the same, right? Because we have a 2t and a 2t. So those variables are the same. Very good, Alyssa Button. Very good, Bridget. Very good, Jaden. And we have the same variable or number by itself. So when we have the same variable and the same constant, this is going to get us a certain type of, exactly, Jaden Ramos, they're twins. It's going to get us a certain type of solution. When you do work to an equation and you're left with the same variables on each side and the same constants on each side, you're not even going to have to take it any further than this. But nice job, Bridget. Bridget said if we were to take this any further, we would subtract 5 from each side. We would be left with 2t plus 2t, because those cancel out. 2t equals 2t. Oh my goodness. We would say divide by 2, t equals t. This is going to say any number that you plug in there is going to make it true. So we call this guy infinitely many solutions. I'm going to go through this a little bit more in detail on the next slide. Now, let's take a look at this next equation here. I have n plus 5 is equal to n plus 7. What do we notice about these ones here? These ones are slightly different. Or this one's slightly different from the first one. Jaden said both of the n's are the same. Good. That's a good thing to notice, Jaden. Very good. What else do we notice? Both of the n's are the same. Very good. We have 2 n's. Both of the n's are alone, so it's a single n. Avery said it's n plus something different. So Kaylee B, if you want to take your mask off, you can do that. You can just spend the whole day without right now for at least, okay? And I'll sort of stay this far out. Good. She said both of the ends are the same, but both sides have a different constant. Very good. Nice job, Avery and Bridget. Very good. So we have the same constants here. Very good. Nice job, Bridget. We have the same constants here. When they don't have a number in front of them, we can rewrite that as a 1n, just like Bridget said. So our variables are the same, but our constants, our numbers by themselves, are different. So if we were to do a little bit of work with this guy, get our n's over to one side, subtract n, we would be left with 5 equals 7, because they cancel out. 5 equals 7, that's never, ever, ever going to be true. So there would be no solutions to this guy. Okay, so let's look at this a little bit more in depth on the next slide. Okay, so on the next slide, we're going to break down these two new ideas and give some examples. No, not bad, Sawyer, very good. We're going to look at some more examples of these two guys here. Let me move my chat over a little bit. I'm going to do something with the other half in a minute. We're going to look at the first half of this first. So we are thinking of this new vocabulary word that we're going to use that's called no solutions, okay, or no solution. So there is no value that you can plug into an equation that would make it true. That's what no solution means, okay? Not a problem, Sawyer, on that. Very good. The x values are going to be the same on both sides, but the constants, the numbers by themselves, are going to be different. So if we look at this example here of 5x plus 4 is equal to 6 plus 5x, we notice that our variables are the same, but our constants are what? Very good, Jaden Ramos. Jaden Ramos said we have two 5x's. And our Avery said that our constants are different. Very good. I'm going to give you another example of an equation that would have no solutions. So for example, negative 3x plus 7 is equal to negative 3x plus 9. Okay? So now what I want you to do is I want you to be creative, and I want you to come up with an equation that would have no solutions. Same x's on each side, but different constants. I want you to take 1 minute right now to do that for me. Boom. Another equation that's going to have same variable, different constants. I'm excited to see what people think. What are people going to write? Ooh, nice job, Bridget. Nice job, Sawyer. Okay, we're going to take another 10. Okay, so the question, Jaden, is, so we are writing our own equation that would have no solutions. Like these two examples that I wrote here, you're coming up with your own one for yourself. Okay? So, Kaylee B, why don't you tell us one that you came up with?
I did 1x plus 5 equals 1x plus 45.
1x plus 45. Yes, girl, perfect. Because our variables are the same, but what are different?
Our
Constants are different. Very good. Very good. Okay, Bridget said 6x plus 8 is equal to 6x plus 1. Very good. We have what are the same? Our variables are the same. Very good, Jaden. We have the 6 x's, very good. But our constants are different. Very good, nice job. Awesome job there, Bridget. Let's see what Sawyer put. Sawyer put 5x plus 11 is equal to 5x plus 14. Nice job, Sawyer. We have the same variables, different constants. Awesome job. We're going to do one more. Avery gave us 19h plus 8 is equal to 19h minus 2. Very good. I like how Avery changed up our variable or our letter. Very good. 19h on both sides. But we have a plus 8 and a minus 2. Nice job, Avery. No problem, Diego. Awesome, awesome. I'm going to leave those up, and I'm going to take a look at the next piece of this. So now that was no solutions. Now we're going to look at this concept of infinitely many solutions, or I like to call it IMS. Okay? IMS means infinitely many solutions. Infinitely many solutions, IMS, means that any number that you plug into the equation will make it true. Okay? So that means the value, the x values are the same and the constants are the same on both sides. I gave an example of 5x plus 4 is equal to 4 plus 5x. My variables are the same. My constants are the same as well. The 4 is a positive 4 because there's no sign there, so that means they are the same. Good. Now I want you to take a minute right now to, on yours, come up with your own equation that would have infinitely many solutions. Nice job, Jaden Ramos. Thank you, my friend. Nice job, Bridget. Nice job, another 24. Coming up with your own and put it in the chat for us so we can see what we're thinking. Very good. Let's take a look. Okay, here we go. Next piece here, infinitely many solutions. Jaden Ramos gave us one of 1x plus 5 is equal to 5 plus 1x. Do we agree, yes or no? Yn. Yes, no. What do we think? Do you agree, Haley?
Yeah.
Hey, Landon. Very good. We agree because we have the same variable on each side, letter, and we have the same constants. Nice job there. That was Jaden. Very good. Haley, did you have one?
I said 4h plus 16 equals 16 plus 4h.
4h plus 16 is equal to, what was the second half?
16 plus 4h.
16 plus 4h. Very good. We notice that they have the same variable or number attached to our letter and the same constant. Very good, Kaylee B. Yes, girl. Fantastic. Let's take a look at another one from Bridget. Or actually, let's go Avery. Avery said 19h plus 8 is equal to 8 plus 19h. That's an h, by the way. We have the same variable. We have the same, let me underline this in a better color. Same variable, same constant. Nice job, Avery. I'm going to pose one more to you guys before we move forward. What if I said this? Okay, I have 37n plus 4 is equal to 37n plus 4. How is that different than all of these other equations, examples that people gave here? Caleb,
Because with the 37 and the numbers and the constants stay the same on both sides, but with the other equations, the constants and numbers switch places on each side.
good. Is mine still an example of infinitely many? Do I have the same variable and the same constant?
Yeah.
Yes, very good. The order is different, but the signs stay the same. So if you write it like this, it can be written as 5 plus 1x is equal to 1x plus 5. We can switch the order like we did here, or it can be written in the same order like it is here. Both of these are still infinitely many solutions. I wanted to take a minute to tell you that because everybody sort of wrote it this way up here. And I wanted to make sure that you knew you can still write it 37 plus 7x is equal to 37 plus 7x, and it's still infinitely many solutions. Order can change and still be infinitely many. Okay? So I'm going to leave that up for a minute. I'm going to start to erase. Think I'm erasing under there? I don't know. Oh, let me go back in. There we go. Here we go. So let's take a look at some equations now, and we're going to make some decisions about the number of solutions that they might have. So let's take a look at the next slide here. We're going to take these one step at a time. So if we're looking at slide number 6 here, I have some equations. Okay? So what I want us to do is I want us to pull this one that says n equals n down, and we're going to look at this one first. Okay? Okay, so what do we notice about this equation here? If we look at this equation, what do we notice? Anything at all? Very good, Jaden Ramos. It has 2 n's. Good. There's no constants. Very good. There are no constants here. There are 2 n's, an n on each side. Very, very good. So if there is no constant on this side, it's like saying plus how much on both of these sides? It's like saying plus, yes, Avery, it's like saying 1 equals 1, but because there's no constant written here, if we were to rewrite it as plus something, it would be plus 0. So 0 plus n is equal to n plus 0. So yes, that's the tricky part, is that we want to remember that when we're given an equation that just has variables like this, it's like saying plus 0. Do you see what I'm doing there? Perfect. So let's think about it. So if I can rewrite this as 0 plus n is equal to n plus 0, how many solutions is this guy going to have? Thinking about those rules for the number of solutions, how many solutions is this guy going to have? Yeah, but look at those variables. Are the variables the same on each side? Nice job, Jaden Ramos. Are our variables the same on each side? Nice job, Avery. Very good, Bridget. Very good, Jaden. Very good. We have, if we look at each side of this, we have a single n, a 1n, and a 1n. Our variables are the same. Okay? So then when our variables are the same, then we need to look at our constants to decide how many solutions it's going to have. So both of these have plus 0 here. And plus 0 is the same, right? So we're adding 0 on each side. So our variables are the same and our constants are the same. So how many solutions is this guy going to have? If our variables are the same and our constants are the same, what did we say the type of solution was going to be for that? How many solutions is it going to have? The variables are the same. Our constants are the same. So this guy is going to have infinitely many solutions because we have plus 0, right? We have a 0. Our variables are the same. Our constants are the same. So we would say that this is true for all solutions or infinitely many solutions. So what you're going to do on your slideshow is you're going to move this equation over to that true for all equation sides. Very good, Jaden Ramos, very good. So does everybody see how we did that? So we had to look at these and say to ourselves, what are we noticing on each side? So now let's look at, so I put it in the middle just so that we could look at it. And then I moved it over to where it belonged. So I sort of, as the teacher, sort of put it in the middle because I wanted to look at it. And then we moved it either way afterward, okay? So let me pull this next one that we're going to look at down. Okay? We're going to look at this guy next. Okay? Oh, okay. I don't know why, Jane Ramos. That's kind of weird. Okay. That's a very good question, Jane Ramos. So now we're looking at this one. What do we notice about this equation right here? Did you hit the space bar by accident, Jane Ramos? Okay. So it has a plus and it has a minus. Okay. Avery said it has the same number and variable, but the sign is like positive and negative. So when we look at our variables, we notice that our variables are what? The same. Do you notice that, Kaylee B? I just don't want you to feel like I'm leaving you out.
No.
Okay, good. So we have the variables are the same here.
And the constants were too.
The thing about the constants is we need to take into account the sign as well.
One is plus and one is minus.
So what kind of solution is this equation going to have then? If it has the same variables but different constants, how many solutions is this going to have? Nice job, JD Ramos. Nice job, Bridget. Thinking back to what we said, when they have the same variable but different constants, it's going to have what type of solution? Nice job, Avery. It's going to have, what do we think? Very good, very good, very good. Because we have the same variable, the same letter, but different constants. The reason that they're different constants is because you need to remember that the sign that comes in front sticks with it. If you need to draw your boxes around it so that you remember, please do so. We have different constants, so this is going to go to the true for no solution, for no values, or it's going to have no solutions. Nice job, very good. I'm going to make this guy a little bit smaller. Oh, wait, no, let me get rid of the ink here, actually. Okay. Now let's look at this next one here. I'm going to make this guy a little bit bigger too. Oh, I made it way too big, but it's okay. So I have this guy here. What do we notice about this guy here before we can get started with this? What do we have to do here? I'm looking at this 3 parentheses n plus 1 is equal to 3n plus 1. Good. Jaden said one side has parentheses and one side doesn't. Bridget gave us an idea of what we have to do before we can make our decision here. About the number of solutions before we can make a decision.
Eastern or central motion?
Fantastic. Okay, so we have parentheses on one side, and we said we have to do something before we can make the decision between no solution or infinitely many. Avery said the parentheses needs the same number of variables, just differently written. Jaden says to be able to make that decision between infinitely many or no solutions, we're going to have to distribute. Very good. So that means I need to take this 3 and multiply it by both of the pieces that are inside. I want you to take 20 seconds right now to distribute this equation. And then make a decision about the number of solutions on what you think.
Take this one with you. And you can take it out later. Sorry.
Ooh, that's exciting. Electives. I can't believe we're already doing that already.
I know, right?
They're trying to get it in case we have to go on.
I can't even believe I'm going to high school next year. I'm so
Crazy.
short.
Right?
Well, some people think I'm still in 6th grade.
It's crazy. It's crazy. So we need to distribute. Very good, Jaden Ramos. Very good, Bridget. Ooh, Bridget already gave us what she thought her answer was going to be. Exciting. So when I distribute, can I, let's do this out. Let's do this a different way. Let's have Gabby Campany. Gabby Campany is there, right? Can you unmute Gabby Campany and can you help me out? What do we think? Want to help me, Gabby? I don't know if she's there. Let's see. I think she's there. Maybe? Maybe not? Okay, that's fine. Oh. Okay, so we'll come back to you, Gabby Campany. I need to distribute. Bridget, can you help me distribute this equation here? Can you unmute and tell me what we're doing here?
You're gonna multiply 3 times n and multiply 3 times 1, and you're gonna get 3n plus 3 equals 3n plus 1.
Awesome job, Bridget. Perfect. Gabby Campany, do you see how we did that distribution? Perfect. So you have to distribute. Now, we're going to look at either side of this, and we're going to think about how many solutions is it going to have. What do I notice when I look at my variables on each side? My variables are 3n and 3n. What do we notice about them? They are
the same.
They're the same. Good. So they are the same. I'm going to put little checks because they're the same. And then we need to look at our constants. And what do our constants on each side look like?
Well, one of them is plus 1, but then this one over here is in parentheses and plus 1.
But so we distributed it, and we said when we distribute that, it distributes to plus 3. So this is sort of like, this is like pre this. So we don't really have to look at this one anymore because we turned it into this guy down here. So we have 3n plus 3 is equal to 3n plus 1.
The constants are different.
The constants are different and our variables are the same. So how many solutions is this guy going to have? So when our variables are the same, that means it's either going to be infinitely many solutions or no solutions, right? So then when we look at our constants here, if they are the same, it's infinitely many. If they are different, which these ones are, it's going to be how many solutions? No solutions. Yes, nice job. So this one is going to be true for no values. Nice job, Bridget. Very good job, Gabby Campany. Very good job, Jaden Ramos and Avery. And that was who helped me out with that one. Very good. So we're going to move this guy over to the values, true for no values or no solutions. Good. Okay, let's look at the next one here. We're going to pull it down and we're going to look at it together. Let me just move these guys up. Okay, we're going to grab, I want you to grab this other one that has parentheses, this 2t plus 6, 2 parentheses t plus 3. So what's my first move when I look at this equation? Before I have to think about the number of solutions it has, I have to do what first here?
You have to see if the variables and the constants are the same on each side.
Good. Can I make that choice yet though, with the parentheses being there?
Well, you'd have to distribute first.
Yes! You, Gabby Campany, and Bridget are perfect. You have to distribute. Yes. Nice job, Gabby Campany and Bridget and Kaylee B. So I have to distribute. Okay? So I want you to take 1 minute right now to distribute these. Simplify the right side and then compare to sort it. Okay? So take a minute to distribute here. Nice job, Bridget. Faith Isabella. Faith is here, perfect. Jaden Jonah. And Kyla Lily. And Olivia and Sawyer and Billy. So we're just missing Allie and Aaliyah today. Perfect. Okay, once you distribute, let me know how many solutions it's going to have. Okay, so I need to distribute here. I need to distribute. I'm looking at this guy here. I'm going to multiply here. Can I have, let's see. Billy, do you mind unmuting? And can you help me distribute this guy? What is it going to distribute to over here? So it's going to be 2t plus 6 is equal to, what do we think, Billy? Billy. What do we think? Billy, are you there? No, Billy is not there. Can I have Avery unmute and can you help me distribute here?
I was like a little confused myself. I think I maybe messed up. So
Okay,
I don't
put it together.
know.
Okay, go ahead, Brando. So we have to multiply 2 times t. What do I get when I multiply that, Avery? That just turns into a 2t, right? Right, Avery? Avery, where are you?
I'm sorry, what? My thing cut out.
So when you distribute here, you do 2 times t, and that just distributes out to a 2t. Then you multiply 2 times 3, and that gets you what?
It'll be 6.
Very good. A 6. What kind of 6?
Positive.
A positive 6. So we're going to say plus 6. Very good. So I distributed it out, Avery, to 2t plus 6. If I compare each side, how many solutions is this guy going to have here? We have this, what do we notice on each side?
That it's like the exact same equation almost. Like there's the exact same numbers and
Same
both sides.
equation. Our variables are the same. Our, what do we call those? Constants are the same. So if our variables are the same and our constants are the same,
Kristen, I was
we say that they have the same.
3211.
They have, how many solutions do they have?
Multiply infinity.
Very good. Infinitely many or true for all values. Nice job. And like Jaden said, they're a replica of one another. I like to call them identical twins. And then I like to call these guys sort of like fraternal twins because they're like almost the same, but there's like a little bit of a difference. right? I like to call them fraternal, but like that's just me being a weirdo. I think it's because I've always wanted to be a twin that I always
Oh,
sort
my
of,
dad's a twin.
oh, I'm so jealous, Haley B. I've always wanted to be a twin. Drives me crazy. Okay, let's look at this guy here. So I have this guy here. Okay? I have on the left side, I have y times -6 times -3. I can combine or condense this equation here. So I can multiply my -6 times my -3 to get what? Let me think. -6 times -3 gets me how much?
That would get you a positive 18.
Yes, Kaylee B. Yo, yes, girl. I get a positive 18 times y, which means the same thing as 18y. Boom. Nice job. So that left side combines to 18y. Now, if I multiply 2 times y, that means 2y times 9. What's 2y times 9? 2 times 9 is?
Well, I don't say 11,
18. And we say it's 18 what?
18y.
Yes. So I have an 18y is equal to 18y.
You can divide 18 by 18.
We could divide 18 by 18. But what do we notice about our variables here?
They're the same.
They're the same. Nice job, Avery and Bridget. So if the variables are the same, and we said if it's just a variable like this, we can rewrite it as +0 plus 0, right? So the variables are the same. Are the constants the same? We have a +0 and a +0. Is that the same?
Mhm.
Yep. So our variables are the same. Nice job, Avery. Our constants are the same. So how many solutions is this guy going to have? Infinitely many solutions, or true for all. Yes, Kaylee B. Scary good today. Not that it's surprising, it's just awesome. I'm so proud of you, Kaylee B. So this guy is going to be true for all solutions because when we multiply it out, we get 18y is equal to 18y. True for all solutions. Very good, Alyssa Button. Yes, girl. Fantastic. Let's take a look at this next one. This one's big, but it's not that bad. So when you look at this equation, what are we noticing here? I have a 5 and I have a -9. Can I combine those? If I have a 5 and a -9, can I combine those? Very good, Jaden Ramos. Think about that sign though. So if I have a 5 and I have a -9, and they don't have any x's attached, if you see that they both don't have any x's attached, I can combine those together. Very good, Bridget. When you can combine them together by saying I have a 5 and then a -9. So what does that combine to? 5 plus -9. Grab a calculator. 5 plus -9 gets me. Very good, Jaden Ramos. A -4. Very good. So these can combine to a -4. And then I can bring my +3x. And we're going to set it equal to, on the other side, I have a -10 and a +6. What do those combine to?
That would also be a -4.
That would also be a -4. Very good. These combine to.
4 plus 3x.
Okay, so this whole thing right here can be condensed, brought together to write it as -4 plus 3x is equal to -4 plus 3x.
So it would go into the true for all values column
And why do you think that, Kaylee B?
because it has infinitely
Many solutions, exactly. And it has infinitely many solutions because our variables are the same and so are our constants. Nice job, Kaylee B and Alyssa Button and Bridget. Nice job. And Jaden Ramos. Fantastic work on that one. That one was probably one of the trickier ones. Okay, let's look at the next one here. We got this fraction guy right here. He's kind of scary, but he's not, I'm not afraid of no fractions. Just like I'm not afraid of any ghosts, I'm afraid of ghosts. I ain't afraid of no fractions. What do we notice about this guy here? What do we think about this guy? It has fractions. What else do you think, Kaylee?
The same variable on each side.
It has the same variable on each side. Good. That's a good thing to notice. The same variable. And the same variable we have here is this x and this x. Good. Avery said she's looking at those and she's saying that they're different fractions. So what are we thinking, Kaylee?
The last equation we didn't put in the wrong column.
Oh, I put it in the wrong column? Oh, you're right. Thank you. Good catch there, Kaylee B. Okay, good. So we said it had the same variables. Avery said that we have different fractions. Alyssa Button said, hey, we should probably put that in true for no values. I know, thank you for catching that, Alyssa Button. Nice job. So we're looking at this guy here. Let me move my clicker out of the way. Okay, so we have the same variables on each side. And we said, Avery said they're different fractions. So what can we say about those constants in general? Very good, Jaden Ramos. That those constants are different. Very good, Alyssa Button. Those constants are different. Our variables are the same, but the constants are different. So that means it is, how many solutions does it have? You think?
I think it would go in true for no value.
Very good. It's going to go into true for no values because our constants are different, but our variables are the same. Very good, Alyssa Button, Bridget, and Avery. Fantastic work today. Alyssa Button's bringing the heat. She's not playing. She's not playing, guys. Okay, now this last one. I say this last one for last because it's a little bit of a trickster. Let's look at this guy. Actually, it's not really a trickster. It's just like we have multiple ways that we can, multiple things that we can do with this. So let's look at this equation here. And let's think, what would be the first thing that we would do to this first? Jaden Ramos gave me an idea. What do you think, Kaylee B?
Distribute the 20D.
Good. We could distribute this 1/4 to each of the pieces inside of there. I like it. It's a good idea. The only thing is Miss Germain is fraction intolerant, like lactose intolerant, but like fraction intolerant. So I like to undo fractions whenever I can. Not quite yet, Jaden Ramos. Let's see why. So when I do this, I like to undo fractions because I don't like to distribute fractions. They're terrible. It's terrible stuff. So what I can do to each side to get rid of this fraction, how did we say that we could get rid of a fraction that we're multiplying by? Instead of dividing by 1/4, we can multiply by what? Very good, Jaden Ramos. The reciprocal, yes, Kaylee B. So we can undo this 1/4 by multiplying by the reciprocal, which is what over what?
Which is 1.
Flip it.
4/1.
4/1. Okay, so that's another way that we can, instead of having to distribute out a fraction, you can do it, but it's risky when you do that. So we can also undo that fraction by multiplying by the reciprocal. Cancels out. We multiply by 4/1. We're left with 20d plus 4 is equal to, what's 5d times 4? I want to say it, but I don't want to say it. How many d will there be? So 5 times 4 is 20 d over 1, right? So we're going to say 20, let me write this underneath. I'm gonna write this up here up top. 20D plus 4 is equal to 20D. So how many solutions is that going to have if we look at it? So what's the same on each side?
It both has 20D on both sides.
Good, the variables are the same. What about, very good, Alyssa Button, our variables are the same. What about our constants?
There's only one constant.
So the left side has a plus 4. And if the right side has nothing, that's like saying plus how much?
Plus 0.
Very good, yes! It's like saying plus 0. I don't know why I got that excited, but it works. So now we can compare our constants. Very good, Alyssa Button. That's a good thing to notice. So when we compare our constants, what do we notice?
One side has plus 4 and the other side has 0.
0. So how many solutions is it going to have?
True for no value.
True for no values or no solutions. Yes, Kaylee B. Yes, Bridget. Fantastic. Alyssa Button, great job, my friend. So this guy is going to come up into this category right here. Nice job, everybody, for playing along with that one. That one was a little bit challenging, but you did fantastic. Okay, so here we go. Whoop-a-ba. So if we're looking at this last one on slide 7, okay, this is where we're ending for the day. Looking at both of these equations here, what do I have to do to this equation first? Before I can do anything, first thing I should do is distribute. Nice job, Kaylee B. Nice job, Jaden Ramos. Multiply 6 times u, 6 times negative 2. 6 times u is going to be written as? Very good, Kaylee B. 6u. 6 times negative 2 is?
Negative 3.
6 times 2 is 12.
Oh,
Negative 12. Very good, Jaden Ramos. Plus 2. Okay, oh goodness. Okay, so I have 6u minus 12 plus 2. What does that minus 12 plus 2 combine to? If I have a negative 12 and then to that I add 2, how many am I going to have now? Very good, Alyssa Button. Negative 10. Very good. It's going to be written as 6u minus 10. 6u minus 10. So, if you want to write an equation for this one, write an equation, the other half of the equation, that would make this infinitely many solutions or true for all values. So what would the other half of this equation have to look like if you wanted it to be true for all values or have infinitely many
it would
solutions?
have to be 6u minus 10 equals 6u minus 10.
Exactly. Because for it to be infinitely many solutions, both sides of the equation need to be
Reciprocal.
the same, right? Or there's not necessarily the reciprocal because that would be the flip. So Jaden Ramos, when you want it to be infinitely many solutions, your variables need to be the same and your constants need to be the same. So it would be minus 10. So then on the other side, we would also have to minus 10. This second one here is where it gets a little bit more creative. We have the equation 6u minus 10. What could the other side of the equation look like to have it be no solutions? This is where it gets creative. Very good. No solution. Yes. Oh, very good, Jaden Ramos. It could be 6u plus 10, 6u minus 77, any number other than minus 10. So for homework this evening, you have 3 problems on Alex that you are going to go in and complete. If you had the opportunity to finish them today during CCR, then you don't have any homework. It needs to get completed for tomorrow. If you have questions, send me emails and I can help you out. I will see you all tomorrow. Awesome job today, my friends. Camera is here. Kaylee, awesome job today. Scary.
What do we do with the slides?
We can turn them in because we are done with them and we're going to move on to something different tomorrow, okay? I just put extra stuff on there in case we had extra time, but we didn't. Oh, that's funny because Alyssa wasn't here, or Leah wasn't here for mine, so. I love it. Fantastic. I will see you guys tomorrow. Have a good one.
Making you dizzy with the camera.
Is anyone else just completely tired, or is it just me?
Just you. We're all ready.
Oh my god, I thought you were Mr. Main for a second. I didn't even know you were.
Oh my god, how are you here so fast?
How am I here?
Main.
Well, they pay me
Yes.
here most of the time, so.
Yeah, but I didn't even see you walk in the room.
For a second for science.
Sneaky.
Rude.
All right, guys. How's everybody today?